Welcome to my third Arduino tutorial. In this tutorial, we will be covering analog inputs and analog outputs. To begin, I will explain the differences between an analog input and an analog output. An analog input is different from a digital input because it can read values not just 0 being off or 1 being on. It can read values very precisely of 1023 different increments. So basically 0 will represent 0 volts and 1023 will represent 5 volts on the pin. So the 5 volts will be split into 1023 equal parts, allowing you to read very precisely, therefore getting very accurate measurements. For example, if you're reading the values of a temperature sensor, you will be able to calculate the temperature precisely, therefore your system will have fewer margin of error. Analog outputs are very similar, but have a smaller range in which they can adjust their value. They can be adjusted from 0 to 255. Through this, you can change the brightness of your LED more precisely. Or, for driving an LCD, you can change the brightness of it more accurately, so it will be more suited for the environmental conditions. To begin, as we have done in previous tutorials, we will have to define the input pins and the output pins. To begin, write #define and the name of the pin, which I will name analog out pin. This will stand for analog output pin, and this will be on digital pin 10. Next, define analog in pin, standing for analog input pin, which will be an analog 3 pin. Analog 3 pins can be found on an Arduino Uno on the bottom left of the pins. On other Arduino models, they may be in different locations, so please look out for the numbers that begin with an A. These will be the analog inputs, which will allow you to read values from 0 to 1023. For analog outputs, you can use any pin on the Arduino. Next, we will want to declare an integer for storing the value we have read. We can do this by writing int read value and set it equal to 0 in case there is an error in the reading. Next, in the void setup, we have to declare the analog output pin. We do not have to declare an analog input pin because analog pins are default set to input unless defined otherwise. To declare analog output pin number 10 as an output, we can write pin mode, the pin number 10, or as we have declared our variable up here, we can do analog out pin and set it to an output. A very important thing to note in programming is that for variables and defines, the first word character is always a lowercase. However, the second words in a phrase is uppercase. This will just allow you to recognize variables more easily while programming. Let's follow on into the void loop function, in which we will set the variable to the value of the analog input. We can do this by writing read or read value equals analog read analog input pin. Now we have set the read value from a value 0 to 1023 depending on the voltage of the pin. Next, we will write this value to the analog output pin. We can do this by writing analog writing the analog out pin to the red value. As I previously mentioned, reading is from 0 till 1023. However, writing is only from 0 to 255, which is a 4-bit number. So to convert the red value to be able to write it, we have to divide it by 4. It's as simple as that. We have now created this program that will read a value, modify the value slightly, dividing it by 4, and writing it out to the analog output pin. This will mean that if we have a potentiometer connected to the pin 10, and we vary that potentiometer, the brightness of a connected LED on analog on pin 10, no, sorry, I said it wrong. The input of the potentiometer on A3 will influence the brightness of the LED on pin 10. Next, we will go over to the circuit view, and I will explain how the circuit works and how to wire your circuit up. Now, over in the circuit view, I will show you how to use a potentiometer wired up to an Arduino to generate an analog input, and how to wire up your LED to a pin 10 instead of pin 8. So, to begin, your LED will require the 470 ohm resistor we have used previously. The shorter pin still connects to ground, and the resistor connects to the LED's anode pin, positive pin to pin 10. That's a very simple circuit. However, the potentiometer is a bit more complex to understand how it works, which I will explain, so in the future when you're wiring it up, you will not just remember how to wire it up, but you will understand why you will have to wire it up that certain way. So, most potentiometers have 3 pins, and usually it is 5 volts, so input, wiper, which is the output, and terminal 3, or ground. This is a 10K potentiometer, which is one of the most common values of a potentiometer, since you can use it for a variety of projects. A potentiometer has multiple coils in it, and as you rotate the knob on the top, which I cannot rotate it because it's not in simulation, but if you have one in your hand, you can see how it rotates. It changes the amount of coils, therefore decreasing or increasing the resistance. As the resistance changes, there will be a different voltage and current on pin A3. A very important thing to note about potentiometers is that if a too large current flows through them, they may get damaged. So you have to make sure that you use a processor such as the Arduino Uno to take an input from it and then wire it up to your output device. As we have written in our code, the analog input pin is A3, which we have it wired up to, and you can see here are the analog pins. The digital pin, or analog output pin, is pin 10, and that's the 2 pins we have wired up. So let's copy this code and paste it into the simulator and upload it and run it. Now you can see the LED is off. However, if I rotate the potentiometer, the LED gets brighter and brighter and brighter. You will see it a lot more in an actual real life situation. However, I think that this digital simulation shows you a good idea of what you can use this project for, and how to develop it further to achieve your needs. Thank you for watching, and hope you enjoyed this video.